All right. So today we'll start inshallah the last chapter in this course. So we have system testing. A quick reminder of everything we covered so far in that course. So we started mostly talking about the process, right? We've seen different types. We've seen the sequential, the waterfall, we've seen the spiral model, we've seen the VV model, we've seen the incremental model, the agile model, the scrum model, right? And we again discussed based on what type of project we can select the best type of the process to ensure good delivery. And of course, it depends on the level of satisfaction that you want to have for the stakeholder. Then we jumped into the SDLC, covering all possible phases. So talking about the planning phase, how to capture requirements, right one functional, non-functional requirements, how to start with the, the priority matrix, how to go into design, how to start building. We have, remember all the types we covered? We have the context diagram, we have use case diagram, class diagram, sequence diagram, activity diagram, state diagram, right? Even timing diagram if you want to add it. And then we looked into implementation. We've seen different types of softwares, different types of languages, IDEs. And we also saw a difference between different team members in one team. Now it's time to see one of the most important phases. And why we're saying important, because many people skip this phase. And this can be a crisis in the project. So if this was not planned well, covered well in the entire cycle, this can actually lead to an entire failure of the whole process. So that's quickly everything we covered last time. And today's session will focus mostly on testing and inspection, testing phases, unit testing, and integration testing. Okay. So let's start with this ideal test pyramid. Let's look here. So if you recall back the VV model, remember, we had the implementation going downward, testing going upward, right? What was the first ever testing phase? Unit testing, right? Then we have component testing, then integration testing, then acceptance testing it was, right? But we can have API testing and functional testing represented in this part. Okay, now comes the question, and you will see this a lot, by the way. Unit test and component test. In many models, these two are just treated like one phase, okay? And they even call it either component or unit, and it means the same thing. And sometimes you will see that they actually split it in two different phases. So we will learn the difference between both of them, and in case you want to design it in a way that's separate, how to do it. So just know that for now, cost and effort increase as we move from unit all the way to functional testing, okay? And the time increase as you move from here to here. So unit test is the one that needs the highest amount of time. And the cost and effort is the highest here when the system is ready, when you're testing it for acceptance testing. So we can say, now testing is intended to show that the program does what it's intended to do, which we already agreed on. We said usually we keep on checking our own final result against the very initial prototype, right? The very initial version of the requirements shared by the stakeholders. If it matches, if the stakeholder is satisfied enough, then we're moving with the right track. So we keep on discovering the program defects before you put it into use, right? Now, we can use artificial synthesized data to check the result of the test run of errors. Okay, who can explain this point for me? What do we mean by artificial or synthesized data? Any idea? Let me give you an example, okay? So you all worked on this assignment that has the elevator simulation, remember? But how did you test it? You haven't tested. What? No, I mean, did you test it physically? Like, did you go to an elevator, counted the time, let's say it takes?
No.
You haven't done this, right? Like, so what you did in replacement? You estimated. Nice, very good. So this estimation is based on fake data, right? But do you think synthesized data or fake data can lead to an accurate data?
No.
It is actually. It is actually. So again, you do it on small scale, right? But you keep good track of variables. So what might change in real life scenario, right? So for example, I assume that it will move from one floor to another, let's say in 4 seconds. Okay, that's my assumption. It might not be realistic, right? But in real life situation, I can fix this value, right? So I'm testing how the output will be generated, how the sequence will be for dropping people or picking them up, right? And if this works as a logic, I can just play with the variables or the constants I have, right? So that's what we call synthesized data, okay? So again, if I want to double check, for example, the effect, for example, of let's make a relation between any two things in life. The relation between drinking coffee and passing exams, okay? Do you think there is a relation?
Yes.
Okay, some said yes. Okay. Anyway, so if you want to test any concept, you put a hypothesis, right? Your own assumption. This assumption can be either validated correctly or you simply prove it wrong. So that's what we do here. We don't have to test everything in real life scenarios. We simply put some sample data, we play with them, we try to see the patterns, the changes, we learn from this, and then we generalize after. So testing is part of verification and validation process, which we explained before, right? And the process is very easy. The process goes into 3 main stages. We have a sample input, we have a process taking place over part of your own system, and then a final output that you want to test if it gives you actually any problem, if it has any defects, or simply prints for you the right result. And this input test case, I don't go for things that are obvious, right? So your test case need to go into things that might cause any trouble with the system, right? So if I'm testing, let's say, a login screen, what will be the test case that you generate?
Right username, wrong password.
When you have a wrong password, right? So this is something abnormal to have, right? So in that case, we do test or generate these test cases mostly to test any abnormalities. Now, we can classify our systems into 2 different types, which reminds you perhaps of a previous conversation. We have the custom software, we have the generic software. So again, if you look into Moodle, for example, this is which one?
Generic.
That's generic. But if you talk about the Moodle made for Faisal University, it's custom, right? So as a software, it's very generic that it can apply to different contexts. But again, you can customize it. In this case, you need to test at least 1 single test for every requirement, and then you will make sure that it's working fine, right? But if you are building a generic software, the variables are more, right? So we do expect more troubles to come. So it might be the case that you have to test all system features, and every feature will be part of hundreds of test cases, not just one. And you will combine most of these features to double check on the integration as well, okay? So again, the more you go towards generic software, the highest the level of testing will be. We have something we know as defect testing. which is concerned mostly with routing any undesirable behavior of the system, like crashes, like unwanted interaction with other systems, like incorrect computation, or let's say data corruption. These are very common, very valid problems that you might actually see in real situations. All right. So we will now clarify between two concepts. We will clarify between inspection and testing. Okay? So we had a previous conversation before that verification and validation has to be part of every phase you make, right? So if you're talking about requirements gathering, there should be a way to tell that this requirement is the right one, right? If you are talking about the design, it has to be also validated against your requirements, and so on for all the remaining phases. So how would we do this? We have what we call it inspection. What does that word mean?
To inspect.
To inspect. So you try to see what's behind, right? If it works correctly or not. That's what inspection holds. So inspection cares mostly in testing your own requirements, your own system architecture, your own design models, your own database schema, and your own program. And again, you will keep on saying, okay, is that the right one? Yes? So every phase will be inspected based on the previously approved phase, right? Then it's time to test. Testing usually goes towards tangible results, like mostly coding. When you start having these small increments, whether units or let's say subcomponents, or let's say when you have multiple modules ready, right? Like at this point, who can clarify to me the difference between unit and component testing? An example. Yes.
Like
right.
units is like testing a very small thing. Like
Excellent.
a component is like pretty much like a whole thing.
Perfect.
But that's still like a component of a system.
Perfect. So if I'm talking about login screen, this is unit or component? That's component, right? But can you subdivide it into units?
Yes, yeah, the password is a unit.
Okay.
The length.
They use the button.
These are attributes.
Oh.
Things that you can test.
Storing users.
Entering.
Storing, that's one. Storing data.
But entering to the doing the login.
Validating.
Doing the login. Entering.
Okay, checking the authentication. Excellent.
Updating.
Updating info. Perfect. Well done. So see, each of them now is a whole separate unit, right? But they all help you finish this component, right? Like it cannot work if you don't have a way to store your data. It cannot work if you cannot update your data or verify if it's correct username and password. So units can be simply methods, right? Can be loops, can be conditions, just any small building unit that can help you have this component up and running, okay? So that's the main idea. Now testing goes mostly for the program. Now when you verify the code, when you verify the requirements, it's time for you to say, I have a ready system prototype. That's well tested, right? Remember when we said we don't count it a requirement if there's no measure to test it? Then that's the case. This has to be well tested. Okay, so this is also important. So polls should be used during the VV process, as we explained before. Inspection can check conformance with the specification, but cannot really test. Cannot conform to the customer real requirements. This is important. We'll explain it in more details in a while. But what's more important now, keep in mind, inspection, the main focus behind it is functional requirements. We don't care much for the non-functional requirements at this stage, okay? So we want to make a check to ensure actually that all of these could reach a point where you say, I'm verifying it against the final code, okay? Please,
So
Jack.
inspection is like testing, but for non-functional requirements.
For functional requirements.
Function.
So it cannot check non-functional, okay? So all of this works mostly for functional requirements, for functional requirements. Now testing could test functional and non-functional requirements. So for example, if I'm building, let's say, a software that analyzes images, okay? And it needs to render for me a result, let's say, within 20 seconds, per my non-functional requirements agreement, right? One way of testing it is telling, okay, this one takes 35, right? This one takes 15. And I try to take the average to see the performance of my model, right? So testing goes for functional, non-functional, but inspection is mostly for functional requirements. Like, during testing, errors can mask or hide other errors. Do you agree?
Is it when it like catches one error and misses the other?
When an error misleads you towards another error, right? So sometimes, and this is a very common trick, you will see it maybe in HTML, which is the most tricky ever markup language you will deal with. You will also see it sometimes with Java. When there is a clear syntax error and it's shown to you, let's say, part of a given line, but when you try to see the source of that line, you see nothing is wrong, right? And it might be sometimes an error up or below it, which is causing this part of the code to not work as expected. So again, this is why we say we don't keep things till it's done and then we test it. We do it incremental testing, right? So as you code, piece by piece, you simply move and double check if it works fine. Makes it easy for you to isolate the error. To say that, okay, it was working a while back correctly, so now since it's misfunctioning, then most likely it's that recent part that I made. All right. Now, incomplete version of the system can be inspected to develop specialized test harness to test the parts that are available. Now, my question to you. Do I have to finish the code entirely to test it?
No.
Like, keep this answer in mind,
Wait,
okay?
actually, yeah. You need an output.
Nice, very good.
Yeah.
Okay. Now keep both opinion in mind, okay? So keep the yes, keep the no in mind. Now consider a product quality attribute of the program, such as compliance with these standards. As we explained before, this is quite important. If we're building something, let's say for accessibility consideration, this has to conform to rules. Same for ISO and other standards available. Portability, maintainability, this has to be considered properly. Type. Let me do a test with you now, okay? Have a look at this piece of code. From programmer perspective, you're all developers, excellent ones. So tell me if this code is written professionally.
It's not.
It's not professional?
No.
What is the issue? What we can fix? Yes.
ما عملوا تحقيق إذا مثلا نقسم على صفر.
Nice. You're saying that this part might be suspicious. Excellent. Very good. Any other bad sign here?
We can add try and catches in case
Excellent.
to validate error.
So we can try and catch, right? To possibly make sure that any possible input from the user is going to work as expected. Very good. That's it?
What's a valid number?
Which one?
Up,
The sum?
no, down.
What?
Where's
This
the
one?
Yeah, it's if it's the user entered a valid number or terminated a valid number.
You're close, Shaden. You're close.
Is it the less than equal to?
Thank you.
Equal.
What is that?
إذا عشان السالب.
So now we're reaching the total length,
Negative. Yeah.
right? Is that true?
No.
So this will end up with exception, right? Clear exception. So there is index out of bounds exception. There is a risk of having arithmetic problem here. So try and catch is quite important, right? This can tell you that no matter how professional you are as a programmer, you might not spot the errors actually really fast, right? So imagine that you're the person who's making it. That's why we say pair programming is quite important, because what you cannot see, other people can tell you about, right? Okay. Now this is what type of testing that you just made? Is it unit testing? Is it component testing, integration testing? It's unit testing, right? Okay. Like in stages, we can talk about development, we can talk about releases, we can talk about users, right? Which one you think is the hardest level of testing?
Music.
Hmm.
I think release.
اليوزر أنا بحس.
طب why? Tell me why. All answers could be valid. But why?
اليوزر أكثر من رأي أكثر من طريقة في
It's hard to satisfy the user, right?
And release.
So at this point, if you fail,
راح
You failed.
right? And if this point fails,
Yeah.
this also
Not good.
propagate. But if this one fails,
It's okay.
you're still at a good term, right? You can fix things. Like, so again, the development testing, its main concern here is to discover bugs. But the release is to make sure that you have a complete version of the system before it's actually released, right? User is when you make sure that whatever you ask it for can actually be delivered, working fine in your own environment as a user, right? Okay, so this brings us to this hierarchy. We have unit testing, integration testing, system testing, and acceptance testing. And we said this together builds up the integration level. We can talk about the component in between if you want, okay? But again, unit leads to components. Components together lead to integration. Integrations together lead to an entire system. Once the system is ready, you go for acceptance testing with the end user. So we spoke about this already, right? So unit test, and this is this is a lot of confusion. Many people, you will see that they call it unit testing, and they call it also component testing. So if you hear it within the same term, it means they are referring to it as the big component. If you see that the description itself is different, then they are considering all possible units that build the entire component. Okay? Let's look into a nice scenario here. So we have a company, my company is being hired by a bank to develop an online banking application, okay? And they made it easy on me, very easy. See this? They gave me the exact level of task that I need to work on. So I need to ensure there is a login using valid credentials. I need to have view current balance. I need to have deposit. I need to have withdraw. I need to have transfer between accounts. Simple, straightforward, right? Now, what can you call each of them?
Components.
Component, excellent. So I did my job as an engineer. I provided a common architecture, okay, that can help me visualize